Hello, so today we are doing this problem called group anagrams, and the problem says that we get an array of strings and we want to group them together. So for example, we get this list, and basically an anagram is, two letters are considered anagrams is if they both are created with the same characters, and these characters are occurring the same number of times. So for example here, eat, and T, we have EAT, and they occur each only once. Tan and Nat, same thing, TAN, and they occur each only once, and bet apart here. So we deconstructed this list into a list of lists of anagrams. So that's what we want to do. So how can we solve this problem? So to solve this problem, the first thing we can do is, okay, let's just write the example and see how can we solve. So the first example we have is this list here. So the first idea that we can come up with is we just need some key to identify all anagrams, and then we can just put the anagrams here, and at that point we can just get the list of values, right? So if we have a map from a key to each list of anagrams, we can find the solution, right? And so what key can be common between anagrams? So the first thing we can think of is just sort the list, right? Sort the string, because if we sort it, we would have something like maybe sorting. When we sort a list, the sorting gives us a unique character, right? Because let's say for eat and 8 and T, which all belong to the same anagram. So all of these, when we sort each of them, we get A, E, T, right? And this is an anagram, right? And this is unique for all of them. And so we can have this as the key and have these as the values, and the same thing with tan and nat. So we will just take all of these and each sort, and each put the value in the map value that has the sorted string as key. And so with that, what will end up happening is we will end up having a map with key and values like this. So the key AET would have the values eat, 8, and T. And then for tan, would be like A and T, I think, or something like that, or ATN, I'm not sure. So essential, but there we would have this like this. And then for bat, it would be ABT, and then we would have only that one. And so to find the solution, we can just return the list of values here, right? So that's one way to do it. The other way we can find unique keys is that so anagram is just they have the same character. So we know that anagram means same characters and same occurrences. So we can just have as key all 26 lowercase characters, because the problem says we only have lowercase letters and each their occurrence. And so letters that are anagrams will have this one as the same. And so for example, for eat, we would have the first, so let's just make them a list like this of all these 26 lowercase character. And so A occurs 1 time, B occurs 0 times, C occurs 0 times, and then we'll continue until E, which occurs 1 time, and then until T, which occurs 1 time, and then the rest occurs 0 times, right? And so this is the idea. And so 8 will have the same representation because it contains 1 A, 0 B's, 0 C's, and then it contains 1 T, and then 1 E. and same thing with T. And for tan and bat and nat, we'll do the same thing. We'll have the representation of an array of all 26 lowercase characters, and then we will put the number of occurrence of each character at its index position. And so that's another way to determine, to have the key. And at the end, we will have the keys as something like this. So our map at the end, in that case, will look like something like this. And so the key would be, let's say, something where we'd have 1, 0, zeros, and then 1, 0, like this. And then the values would be 8, T, and 8. So these would be the values. And similar thing for tan, nat, and bat. And so at the end, we can just take the map values. So just take map values. So these are all different types of converting the strings into a canonical representation, such that each string that is anagram of another, they have the same key. And so another way to do this again is using prime numbers. And so basically what we are going to take advantage of here is the fundamental theorem of arithmetic, which says that any number can be converted as any number can be converted as a unique product of prime numbers. Computed as a unique And so what we are going to do here is that we are going to represent our key is going to be a number, and each character of the strings that we have here will be mapped to a prime number. And so for each occurrence of that character, we will multiply by that prime value. And so since we will get a unique number, all strings that have the same number of characters and the same number of occurrences of these characters will have the same unique number here that is represented as a unique product of prime numbers. And so, for example, let's say we will have, so since we have only 26 characters, because it's all lowercase, that means we need only 26 prime numbers. So we will take the prime numbers 2, 3, 5, 7, all the way until we have all the 26 first prime numbers. And our key would be constructed in this way. So our key would be something like, for 8, let's say, it would be A is correspond to 2, B to 3, this one C, and so A would be 2, and since it occurs only one time, to the power of 1, plus T, which let's say I can't know exactly, but let's say it's just some prime number I, one of these prime numbers somewhere here, to the power of 1, since T occurs only once. If it occurs 2 times, we'll have to the power of 2, and then plus E, which let's say it's PG somewhere here, to the power of 1 also, since it occurs 2 times, right? And so each would have the same value because it's 1A, 2 to the power of 1, plus 1E, PG to the power of 1, and T, which is PI to the power of 1 again. And same thing with each, and same thing with T, and a similar thing happens with tan and bat and nat. Okay, so now we would end up with the same thing we did here, where we would have a map or groups, let's say, where the key is a number. So let's say here the key would be maybe, I don't know, let's say here it was 123, 4, something like that. It probably not that number, but the key would be a unique number because it's just a sum of a product of values. And here we would have the value as eat, ate, and tea, and a similar thing for tan and nat, and a similar thing for bat. And so we could return at the end just this group's dot values. And so here we saw 3 different solutions, but all follow the same idea, which is convert string to canonical representation, which basically just standard representation that is the same for all anagrams. And add values of those strings that have that representation as values for that key, and at the end just regroup the values. And so we would have this first one, which uses sorting, and then we had this one, which uses just occurrences of characters as an array, and here 3, which uses just prime factorization. Okay, so now that we have our ideas, let's look into implementing all these 3 solutions and code them up and submit them. Okay, let's get it. Okay, so let's implement the first solution, which was to convert them all to make the key as a sorted representation of the string. And so first we need the groups, which is just the map that will have the keys and the values. So let's just make it a default dictionary of list. And for every string in the list of string, we would have groups of the key, which is just the sorted string. But since a list, you can't have a list as keys as a key, I'm just going to convert it to a string by joining with an empty string like this. And then we would add that string, since this is the unique representation of anagrams, and this string is part of that group. And at the end we can just return group.values. Groups. It's taking a little bit of time. Okay, so we can see it seems good. Let's just submit. Okay, so that passes. Now let's do the second solution, where we use the occurrence of characters. And so for that we need an array that for each string instead that has all the lowercase letters. And now we will just go through each character in the string and mark its number of occurrences in count, right? And so to do that, we'll just say count, and the index is going to be just this, because this gives us a nice way of indexing through the characters. Maybe I should show an example of that. So basically, order of, let's say, E is this value 101, but if we subtract order of A, we'll get its exact index if we take 0, 1, 2, 3, such that order of A is 0. So for example, the index of A itself is 0, the index of the letter after that, the lowercase letter after that, sorry, not 1, B, which is the letter after B, the index is 1, C, the index should be 2, so it's ordered indexing. And so now with that we need to mark it that we have 1 occurrences of this character C, and so we need to add 1. And so at the end of here we would have this count array that has the number of occurrences of characters where each value represents the number of occurrences of the character represented by that index, right? And so now the key is going to be that count array instead. But since in Python you can't have a key as a list, we can just convert it to a tuple, which, to give you an idea of what that will look like. So if we have this, and let's say just 2, the character at index 2 would add 1, or let's say add 2, and then let's say for 4 add 1. So count would be something like this now, right? And so if this is a list and can be a map key, now if we convert it to a tuple, it would be like this, and this is accepted as a map key, because if I have groups as collections.default dict of list, and I have groups of, let's say, let me just show you a key that is an array. What will happen? So in that case, Python complains that list is an unhashable type. But if I convert that list into a tuple, I get a valid key, right? And so that's what we are doing here. And at the end, since this is a unique presentation for each anagram, we can just get the values. Okay, so that solution passes. The other solution was using primes, right? And so the primes, we need a prime representation. We need the 26 primes, and since I don't have them, don't remember them by default, I have them copied here. So these are all the 26 prime numbers. And now our key is not going to change, right? So our key is going to be something else. And so let's just initialize it to 1, because we are going to do the product of primes, right? And so what we are going to do is, for each character in the string, we are going to multiply by its prime representation, so that we can get a sum of product, so we can get all the products of that character occurrence, right? So that would be primes of, and the same way we did earlier to obtain the index in the array, we are going to do the same thing here, and that would be -a, and that gives us the index. And now we have the key like that, and we can just append, and this is a unique representation of each anagram again, and so we'll get all the values added into that key. Okay, so let's submit this solution, and that solution passes. Okay, so these are the different ways you can solve this problem, and all boil down to the same thing: having a key that is unique per anagram, and putting all the values on that key, and at the end just returning the values of that. Yeah, so that's it for this solution.